Hello class, we are in page 277 in the arithmetic books. Today we're going to learn how to annex zeros when we are dividing. Whenever we were dividing, sometimes we actually had a remainder, and when we wrote down the remainder, we wrote it down as R.2, R.5, depending on what is our remainder. Today our lesson is going to be that we don't want a remainder, but we want to continue dividing. Now, how are we going to continue dividing when we have a remainder? So if rule says, as we are annexing zeros when dividing, the rule says to avoid a remainder or a fraction in the quotient, annex zeros after the decimal point of the dividend and continue to divide. So we are going to continue to divide even though we have a remainder by doing what? By annexing zeros. So in the parentheses it says all whole numbers have an imaginary decimal point after the ones place. So what I'm going to do when I am showing you an example, my first step is going to be adding that imaginary decimal point to my dividend. So let's go to move on to my example. My first example is 4 divided by 30. 4 divided by 30. As I said, my first step is going to be add my imaginary decimal point to my dividend. So where's going to be my imaginary decimal point? There is always an imaginary decimal point after the ones place. But remember our lesson that we learned yesterday. Where are we going to place our decimal point in our quotient? Directly above. So let's go ahead and place our decimal point right there. And then let's go ahead and do our division. How many times can 4 go into 30? 4 can go into 30 7 times. So I'm going to write down that 7. 4 times 7 equals 28. And I have a remainder of 2. But remember, today's lesson is I don't want to have a remainder, but I want to keep dividing. How am I going to keep dividing? I'm going to annex a 0 to my remainder. So I have now 4 into 20. Now, how many times can 4 go into 20? That is 5 times. 4 times 5 equals 20. And I will end up having no remainder. As you can see, my first step was what? Add my imaginary decimal point, then place my decimal point directly above for my quotient, and then I'm going to keep dividing. Once I have a remainder, I'm going to annex a 0 to keep dividing. And my final answer is 7.5. Let me go ahead and show you another example. My next example is going to be 8 divided by 52. 8 divided by 52. My first step is going to be adding that decimal point, my imaginary decimal point from my dividend. So my dividend is the 52. My imaginary decimal point is after that ones place. So it goes right here. Our lesson yesterday said place the decimal point directly above for my quotient. So that's my decimal point is going to go right there. And let's go ahead and start dividing. How many times can 8 go into 52? 8 can go into 52 6 times. 6 times 8 equals 48. Let's go and subtract 52 minus 48. I cannot subtract 2 minus 8, so I'm going to borrow from my 5, make that a 4. My 2 becomes a 12. 12 minus 8 equals 4. 4 minus 4 equals 0. So I said I don't want a remainder, so what I'm going to do, I'm going to annex a 0 to my remainder, and I'm going to keep dividing. So how many times can 8 go into 40? 8 can go into 40 5 times. 8 times 5 equals 40. 40 minus 40 equals 0. And my final answer is 6.5. Just remember to always add your imaginary decimal point and bring up your decimal point to your quotient. And whenever you're done dividing, remember you're not done because you can keep dividing by annexing zeros. So as you can see, I annexed a 0 right here and I kept dividing and I ended up having no remainder. Your your class for today is going to be page 277. You're going to do all page 277. Goodbye.